Hi everyone, today we're going to start 10.2, which is find arc measures. And our goal is to use angle measures to find arc measures. Arc. An arc is a set of points on a circle between any 2 points. So this red line on the outside of the circle is called an arc. And there's 2 ways that we could write this arc. You could actually write out the word arc, as in the picture, arc RS. Or if you draw this little arc above RS, we know that that's talking about arc RS. Measure of an arc. A measure of an arc is the amount of the circle in degrees traced by the arc. So anytime we're talking about measures, we're going to use degrees. A semicircle. A semicircle is an arc whose endpoints lie on the diameter. And we know that the measure would be 180 degrees. So once again, we have our arc here. We know this is a semicircle because it's half the circle. It lies on the diameter, and this measure is 180 degrees. A minor arc. A minor arc is an arc that measures less than 180, and we name it by their endpoints. So if we're talking about this red arc here, we call this minor AB because that's where it starts at A and it ends at B. A major arc. A major arc is an arc that measures more than 180 degrees, and we name them by their endpoints, and we actually use 3 points here. So to distinguish between minor arcs and major arcs, we always name major arcs by using 3 letters. So if we look at our example here, this is arc A, D, B, and remember order matters, so that letter D has to be in between. A central angle. A central angle is an angle whose vertex is in the center of the circle. So if point C here is the center of my circle, I know that this angle measure here is actually going to be the same measure of this arc. So for example, if this measure for that angle is 25 degrees, that means that this arc measure is also 25 degrees. Now this only works if you're looking at the angle that's in the center. So the central angle and the arc that is formed with it has the same measure. So let's practice naming minor arcs. So a minor arc is an arc that's less than 180 degrees. So where do we see some minor arcs? Let's start with arc EF. So arc EF is right here. This is a minor arc because it's less than 180 degrees, which means arc FGE would be a major arc. It's greater than 180 degrees. We have another minor arc with arc IJ. And in that same circle, circle H, what's the last minor arc that we see? It would be arc JK. And we see that we have ILK. Would that be a minor arc or a major arc? Well, it's a major arc. It's greater than 180 degrees. Lastly, we ask about semicircles. So a semicircle is an arc that equals 180 degrees. And so there's only one here that we see. It would be arc BC. And even talking about this arc here, that's the same arc, arc BC, also a semicircle. Next, we're going to find measures of arcs. So we want to find the measures of each arc in circle P, where RT is the diameter. So right now, we know that this measure here is 110 degrees. So which arc is also equal to 110 degrees? Well, it would be the arc that's associated with that angle, which is right here, and that is arc RS. So for A, we know that that arc is equal to 110 degrees. Now we need to look at our circle and see what we know and what we need to find out. Well, if you look closely, we see that we have a semicircle here from T to R, which means if it's a semicircle, it's 180 degrees. So if I know that this is 180 degrees, I also know that this arc is 180 degrees. And if we look at our choices below, that would be arc RST. So we know that this is 180 degrees. Now the last arc we need to focus on is RTS. And R, remember order matters, so we start at R, we go to, we go to T, and then we go to S. So I need to figure out what is that measure. Well, I first need to figure out what is this measure here. Well, once again, we know this is the diameter. If we know that part of that diameter or that semicircle is 110, when we add those up, we get 180. So that means that this little sliver has to equal 70. So that means that this part of the arc is going to equal 70. So to figure out the measure of arc RTS, I'm going to do 180 plus 70. Add those up, we get 250. Arc addition postulate. The arc addition postulate states that the measure of an arc formed by two adjacent arcs is just the sum of the measures of the two arcs. So just like what we did in that last example, we added up the two measures that we knew to find that big arc. So if I'm looking at my example here and I want to find the measure of arc ABC, I would add up the red arc and the blue arc to find that large arc. Find measures of arcs. For our survey, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measure. So we're going to start with A, measure of arc AC. Since there's two letters here, we know we're looking at a minor arc. So AC has to go this way. We could not go the other way. We could not go this way because that would be a major arc, and we're only looking at the minor arc. So if I'm looking for the measure of arc A to C, I need to add up this angle measure and this angle measure up together. And when I do so, I get 137. B, we want to look at the measure of arc ACD. So A, we start at A. Let's try that again. So we go from A to C to D. So I need to add up this angle measure and this angle measure and this angle measure together this time. And when I do so, I get 220. Next, we're going to find the measure of arc ADC. So we have a major arc here because there's three letters. So A, we're going to go this way, DC. So I need to add up these measures here. And when I do so, I end up getting 223. And the last major arc is EBD. So we start at E, we go to B, and then to D. And we could add all of these up again. And when you do so, you get 299. Oops. Or we do see that the only slice that we're not focusing on is a 61. We know that a circle is 360. So another way we could have figured this out is just doing 360 minus 61. And we get the same answer of 299. Congruent circles. Congruent circles mean that two circles have congruent radii. So if we look at these circles, we know that these circles are congruent because the radius here has one tick mark, and this radius also has one tick mark, meaning those two circles are congruent. Congruent arcs. Congruent arcs are when two arcs that are in the same or congruent circles, then they have the same measure. So if I look at this circle, I notice that this angle measure and this angle measure are the same. They're the measure of x, meaning that our arcs are also the same measure. Identify the congruent arcs. Tell whether the red arcs are congruent and then explain why or why not. So let's look at A here. Are these two arcs congruent? Yes or no? The answer is yes. And why are they congruent? Because we see the center here. We know that these two measures are the same, meaning that our two arcs are also the same. Let's look at B here. Are these two arcs the same? Is this arc the same measure as this arc? And hopefully you can kind of see this in the picture. The answer is no. And why? Well, we don't have two congruent circles here. It's pretty obvious to see that this circle is much shorter than this circle. So even though this would be 90 degrees and this would be 90 degrees, their length, as in the size of these arcs, are not congruent. And then how about C? Are these two arcs congruent? This arc and this arc? Yes or no? Well, this would be yes. Why? Well, these two circles are congruent, and we see that because they have the same radii. So since the radii are the same, and since the arc measures are the same, we can then say that those two arcs are congruent.